time, problem solving on sequences. You can see the lesson in your learning activity sheet, page 3, lesson 8. Lesson 8. So there are some examples in your activity sheets. Let us discuss them. The first example is Jose saved from his school allowance as follow: 15 pesos on the first week, 20 pesos on the second week, and 25 pesos on the third week, and so on. How much was his total savings after 50 weeks? So with this word problem, the first thing that we need to decide on is to choose between arithmetic or geometric, because we already know that there is a pattern involved with the numbers 15, the savings on the first week, which is 15 pesos, and then followed by 20, and the next is 25. So we can see that there is a pattern here. But what is the sequence involved in this pattern? Is it arithmetic or geometric? What do you think? You can use the chat box for the
Arithmetic
answer.
po, ma'am.
Arithmetic sequence
Correct.
po.
Very good. So arithmetic sequence. Why? Or how did you decide that, or how did you determine that this is an arithmetic sequence?
May common difference po na 5.
Okay, very good. Because there is a common difference, which is 5. So if there is a common difference represented by small letter d, that is an arithmetic sequence. Okay, so d equals 5. So we can now state the given. We have the common difference 5. We have the first term, which is 15. And then we also know that we are looking for 50 weeks. So we use n equals 50. And with that, we can now solve the total savings by first using the formula for a sub n. You can see that in your activity sheet. So you write a sub n is equal to the first term plus the quantity n minus 1 times the common difference. So let us use an equation to emphasize the subscript. Okay, we have a sub n is equal to a sub 1 plus the quantity n minus 1 times d. And then with this formula, we can now replace those which are given from the problem. We have the first term, which is 15. We know that there are 50 terms in the sequence, and we know that the common difference is 5. Next step is to solve this equation by simplifying the equation using the operations. 50 minus 1 is 49, and then multiply 49 by 5. Multiply first before add. So 49 times 5 is 245, and then after that, we need to add 245 plus 15, which is 260, which means on the 50th weeks, 50th week, sorry, on the 50th week, Jose saved 260 pesos of his school allowance. And after that, that doesn't end the solution, because what we need to do is the total savings. What do we need to solve to find the total savings? To accumulate the his savings from week 1 to week 50, which is 260. What do we need to do to find the total savings? Anyone from the group? You can type your answer in our chat box, or you can simply unmute your microphone and tell us how can you find the total savings after 50 weeks. We need to use the formula for arithmetic series, because we need to find the total or the sum of all savings from week 1 to week 50. And we know the formula, we will use next slide for that. So we will use next slide. So we know this given that a sub 1, so take note that we already know that the first term from his savings is 15, and we also know that the last term or his savings during the 50th week is 260. And of course, we know that n equals 50. Only these three things are needed in order to solve for the sum of all savings from week 1 to week 50. The formula states that the sum is equal to the quotient of n divided by 2, and then we need to add the first term plus the last term, which is ace of n. So use the formula in order to solve the problem. Replace now n with 50 from the given. Replace the first term with 15. Replace the last term with 260. And then apply the operations. 50 is not divisible by 2. You may simply start with 15 plus 2. 50 is divisible by 2, sorry. You first, you first need to divide this to simplify the equation. So divide 50 by 2 equals 25. And then we add first 265 plus 15 to 75. And finally, to find the sum, we need to multiply 275 plus 25 equals 6,875. That means the total savings of Jose after 50 weeks is 875 pesos. Any questions with that problem and the solution?
None po.
Wala na po, ma'am.
Okay. Let us move to the last example. We have an example in page 7, example number 5. A group of mountaineers who climb Mount Asog. Mount Asog is a mountain in Iriga City. During summer, doubles every week. If there are 15 climbers for the first week of the summer season, how many mountaineers will there be on the seventh week? What will be the total after the first 7 weeks of summer? Yeah. So from the statement doubles every week, from this statement alone, we can now decide that this sequence involves geometric sequence. Doubles mean times 2, meaning the formula is multiplication or the operation multiplication. Therefore, we need to consider geometric sequence. Let us now list the given. The first term from the problem is 15. So in the first week, there are 15 climbers. So 15 is the value of a sub 1. And then we know that the common ratio is 2 from the word doubles times 2. Therefore, the common ratio is 2. And then n is 7 from 7th week. Okay. And then we now proceed with the formula. We need now to use the formula for for geometric sequence, which is a sub n is equal to the first term times times the common ratio r raised to n minus 1. So that is the formula for geometric sequence. We now replace those variables with the given from the given 15, and then common ratio is 2, and then the exponent is n minus 1, which is 7 minus 1. And then let us continue the solution by replacing this with 6. So 6 minus 1, 6 is derived from 7 minus 1 equals 6. So we have a sub 7 is equal to 15 times 2 raised to 6. And then continue the solution by first applying the exponent. So we have 2 raised to 6 is 64. And then finally, find the product of 15 and 64. It will give us 960. That means in the seventh week, there are 960 mountaineers that climbed Mount Aso. Now, we need to find the total number of mountaineers for the entire 7 weeks. We now need to use the formula for geometric series. And we need here the first term. We still need the first term, which is 15. And then we also need the value of n, which is 7. Let us now go back with the formula from our lesson last time. Geometric sequence, we have s of n, geometric series, is equal to the numerator of the formula will be a's of 1, and then we multiply it with the quantity 1 minus r raised to n, and then finally we divide it with 1 minus r. That is the formula for geometric sequence, a geometric series. So we have 15 here, and then 1 minus 2 raised to 7 all over 1 minus 2. And then we simplify the given equation. So we need first to apply the exponent. 2 raised to 7 is equal to 128. And the next step is to apply subtraction first. Inside the parentheses, we need to subtract 1 minus 128 is negative because we subtract a bigger from smaller. So negative 127. And the next step is to multiply the numerators. 15 times negative 127. So the answer, the product is obviously a negative number. Negative 1905. 1905. Well, the denominator can now be also subtracted. Also a negative number because 1 minus 2. And as you notice here, we have to divide negative divided by negative. And the answer is of course positive. 1905.